Okay. One of the things we're missing for the assignment is OpenStack, right? So some of you noticed, I think Marsh talked about it yesterday, we removed the Docker requirement, so we deal with this afterwards. But you still want to run your software somewhere, right? So and in order to do that, the idea was to use OpenStack, as we mentioned some time ago. Last week I posted an issue with respect to the setup of OpenStack. You may or may not have seen this. I'll bring it up for the sake of reference, because we come back to that later. And that describes basically, no, it points you to the resources that allow you to set up, basically your OpenStack instance, but without telling you much what's happening behind the scenes. So we do a bit on that, but very briefly. Hang on. OpenStack setup, there you go. And you find the pointers to resources, so you can refer to that, back to that later, but I'll come back to that. So what's OpenStack? Well, without much further ado, well, the key idea is that it's one of an example of an IaaS infrastructure, right? So we talked about the differentiation between infrastructure, platform, and software as a service, and whatever else you may want to know. And how do they typically look like? Well, they are, the idea is there that in addition to virtualizing services or abstractly representing some sort of platform that supports certain programming languages, please.
There's a question over here.
Where? So, sorry.
The stream's not on.
That should, well, it tells me it's running, so let's see. Can anyone confirm this? I'm connected with 2,600 kilobit second.
Yeah, just keep going, I'll check.
Yeah. Anyone else confirming? Else I can restart it. I think I have a local recording, so I could upload that in worst case. So the idea there is that we're not virtualizing only an environment that you can upload, your software, your executables, and they're run there. But in addition, it virtualizes the complete infrastructure that you can actually modify. So you can configure your own machines, like virtual computers, virtual machines, as referred to your own storage, so your own hard drive, for example, but also configure networking and the like, and so on. So that's a typical setup of how it looks like. We have a separation into computing facilities, into storage facilities, which represent your hard drive, networking, imaging, we get to that in a second, object storage, and of course the identity service, because the idea is that it's like a cloud service in which you need to identify yourself, and you may have certain permissions to, of course, your own VMs, but perhaps also other people's VMs, and so on, right? So there's a bit more need for identity service associated with this. And then if you want to go into more details, here it's separated by actual physical nodes, how they would be represented, generally one or more machines that take up certain parts. In particular, in OpenStack, there's a lot of weight on the controller node, which coordinates the entire system. So it's not really distributed in a strong sense, but the controller is inherently centralized. And then we have networking compute nodes that do certain other facilities with respect to networking. For example, the emulate switching, DHCP services in a network context. We may touch on that to some extent later. And of course, computing, how this is realized, also something we need to touch on later. So the only thing I want to leave you with is that this system is reasonably complex in terms of its operation, and it's generally unified by some sort of user-facing dashboard in this particular case called Horizon. That's the node entity as part of OpenStack that we will be interacting with, which basically pokes into all those services and composes your virtual machine that you see as something you can manage. But fundamentally, it's actually running across different nodes in this OpenStack setup. So that's basically the message I want to get across now, because then we'll see it. So here's one slide. There's actually a way of running OpenStack on your local machine. I would be very hesitant recommending this, because you need to have serious punch on your own machine, but DevStack, you can actually do that. But we have our own deployment here, and that's what we're going to use. And it's called SkyHigh. It's run downstairs by in association with EEC in particular, so that's where it's managed. And they offer actually quite nice introductory documentation that just helps you to get started. Again, that's all linked in the issue. That is basically a walkthrough, including screenshots, that just tells you how to set up your virtual machine. So that's relatively straightforward idea. But I run you through some essential points so we don't get confused. So this slide kind of sums it all up. So fundamentally the idea is, if we go into this system, I'll just go there directly. Again, that is the URL that is provided here. You'll see the pointer to the login, and you'll see a pointer to the introduction that is provided by EEC. So relatively straightforward, plus some other notes, but some of them I will highlight now. First of all, if you log in, especially if you have been OpenStack user before or currently are, be mindful that you work on the right project. So you may have multiple projects up here. They may be called different names, ED, EEC, whatever else. But in our case, ours is called IMT2681, H19, right? And then followed by your enter new username as a suffix. So that's important, else you're creating your projects elsewhere. I mean, you can do that, but you're eating into other resources. So what you see here in this overview is basically your resource availability, right? So on the left side, you see the number of instances you can create. In this case, you should all be able to create about 3 instances of whatever nature. Virtual CPUs, so you also have CPUs. You can distribute RAM, floating IPs, security groups, we get to that, and volumes as well as volume storage. So volume storage, for the sake of simplicity, see that as your hard drive storage you can use. Floating IPs is a bit trickier. I'll come back to it in a second. And security groups, which is another concept that's essential in this context. So because you need to do a bit of kind of networking, but again, luckily the tutorial does the heavy lifting for you. So if you then click into instance, for example, you see the instances you're having. Well, in this case, none. That is fair enough. You get a point towards images. In the previous slides that I just showed, there was a component that manages images. And that's where you come back to this one here. It's basically all the ready-made virtual machine images that you can possibly use that are provided already out of the box by the guys downstairs and managed by them as well. So including CentOS distribution, Debian, Linux, various versions. And one of them is Ubuntu Server 1804 LTS in the 64-bit version. I'll just point you to this. The reason we're so explicit about it because is that this is the version that we're going to use and assume that you're using. So everything will work that we may do in the future on it. So it's important. 1804 LTS, long-term support. I think Marius highlighted this in one of the first lectures on Linux, that this is the most stable version that you want to run if you deploy something on a server. In general, unless you try something really cutting edge on more needed development machine. And you have the AMD 64 suffix, which means it's a 64-bit architecture. It means all the software that we're going to use will run on it. If you take the 32-bit one, usually denoted as i386, 32-bit, yes, then some of the software may not run. So that's the key idea there. So before you start creating instances, there's 2 things that need to be done fundamentally. One of them is you want to create a so-called key pair. So you just do that relatively straightforward by saying creating key pair, giving it a name, and then it allows you to download. It allows you to download a file, which I'm of course not doing right now, but fundamentally it's a .pem file, and this is your key file that you're going to be using to connect to your virtual machine. I go back to that in a second, what that particularly means, but this is important that you generate this first so you have it at hand. The thing is, you need to keep track of that file, but you only do it once because you can reuse it across all your virtual machines if you want to, not necessarily professional, but for the purpose of the exercise here and you creating your machines, it will ask you which key file you want to use, so you want to have one generated at that point in time. So I have my standard pair, for example, that I use for all my virtual machines. It just sits there. That's something you do once. The other thing that is a bit painful here, we talked about the fact that we are emulating infrastructure, is that you're fundamentally running an isolated network, and completely isolated infrastructure and isolated nodes that are not connected, at least in the default variant, with the NTNU network, meaning let's call it the internet for the sake of simplicity, meaning your machines wouldn't have access to the internet. In order to do that, you kind of need to create an internal network first. And that's also one thing you do once, where you basically create a network. You need to provide you need to define a subnet. Again, just literally use the numbers that are in the tutorial. There's no point to vary on that one right now. We can we talk about this later, otherwise we spend too much time on that. And you're going to create a network that is connected to a given router. And this router has an internal and external network. The internal network is the one you created, so going back to this one, and the external network, here called external gateway, is the NTNU internal. So just going back to the topology, that's always good for debugging. So on the left side, you see NTNU internal, internet. You see the small globe symbol at the bottom there. Then you have this square in the middle, that's the router that you're going to be creating. And then you have this thing called my network in this particular instance. In fact, you give it the name. That's the internal network that your virtual machines will be connecting to get the point, right? So there's no other way of directly connecting to the internet, if you like. You need to have this internal network. But that's described in the tutorial of how you go about this initially. What else is important? Yes, so one of the challenges is, given that you have this internal network, you want, in our case, we have the special situation that we're running servers. And we want to make those servers accessible to the NTNU network, not the internet, sorry. So everything you do, if you want to access your servers, you need to be on the NTNU network or connected via VPN, like the submission system, same problem. So that's roughly a level of public connectivity that we're going to get. If you want to do that, there's no easy way of directly poking into your machine that sits behind this router on your side. But in order to connect your virtual machines with the, so basically to bypass this or provide a shortcut, if you like, to the NTNU internal network, there's a concept of so-called floating IPs. So I'll demonstrate this in a second just by running an instance, and it's hopefully a bit clear of how that could possibly work. So if you go to instances and click launch instance, then you get basically a massive selector of things you can do. One of them is of course providing instance name. Let's use this one, always works. Availability zone, there's only one. You only create one machine at a given time. I wouldn't recommend to do more than this. You want to, there's various ways of creating your virtual machine. The one you want to use is called image, because that's one of the images that you just saw before. You can also instantiate virtual machines from snapshots you took from other virtual machines and so on. We're not talking about this here. But then you basically drill down. Be mindful, don't take the Ubuntu server 1804 LTS i386, but go a bit further and you'll find the AMD 64. It's important because not everything, well, for this assignment you'll be fine, but not everything we're going to see in the future will run on this version.
No, didn't you have troubles like installing Git on that?
On which one? On 64?
No, the 63 one. The
32-bit doesn't run Docker Compose. Is that your?
Oh yeah, it was Compose. Yeah,
that's right.
Compose. So
there you go. So not that we deal with this right now, but in any case, that will come back to you. So you will need to reinstall, reset it up again, which is kind of annoying. A good instance. So next thing. Well, now you have picked the operating system you want to run, which is good. You also need to decide what virtual hardware you want to run it on. So you need to get your feeling. So what we have here in OpenStack is the notion of flavors. That's fairly similar to what you'd find in AWS and other platforms. They call them, using different terminology, but fundamentally they usually have some sort of abbreviation. Here's like something like T1, C1, M1, and so on, followed with a suffix. And then the actual hardware characteristics that you're going to emulate, right? So it includes the number of CPUs, RAM, the disk size you're going to have, and those are major features I think you want to pay attention to if you want. We don't need much juice really, but I generally would recommend, since you're probably only running one instance or so anyway, to perhaps use just M1 Tiny. I think that's a decent setup. So especially if you want to scale up in your project and so on, use a bit more RAM, then you have a bit more leeway. If you take the T1 small, the one here, which is one CPU, 512 megabyte of RAM, it's okay. It will probably be fine for our assignment, but it may be challenging in there. So it's safer choices to take M1 Tiny, which has 2 gigabyte of RAMs and should satisfy your purposes. So you just click on this arrow here, and eventually it will highlight this as the selected choice. So when you, if you have a set up network already, you simply don't need to do much. You just need to ensure that your network is allocated, so it's actually connected to that one. If you have additional network ports, we're not dealing with this. You can just forego this. Yes, one other important aspect are security groups. I should have shown that slightly before. So security groups is basically, think about it, your firewall. The problem is, if you run your virtual machine on your local machine, you don't really, well, you should, but you probably don't really care about security too much, right? You spin it up, and then we go from there. Bear in mind, everything you do in a public cloud environment, so in this OpenStack could in principle be one, well, is publicly available immediately, right? So anyone can, well, ideally not, but possibly, attack your system or, interact with this to some extent. So you get to get the guards up from the get-go, meaning we need to have some sort of firewalling principles. And there are various security groups that you use for that purpose. Basically, it's a set of rules that you apply in order to restrict traffic to your virtual machine. I'll just... Yes, so we have the default security group, which basically allows your virtual machines that are created to communicate outwards. So basically, they can connect and download, you can run apt-get. They can configure, they can do HTTP requests, but what they can't do is, well, receive incoming requests, right? They're not open for this one. So that's the only constraint that we are seeing right now. And one of the incoming requests that we need to deal with is particularly SSH. That's the one that we are particularly interested in. And this is basically your means of accessing those virtual machines. Because think about it like a remote access protocol for now that we need to have. For this protocol, we have you would need to create a separate default security group. In the tutorial, it tells you to modify the existing default security group. It will work, but everyone being in InfoSec downstairs will say and will shout and throw tomatoes at you because that's not the right way to do. You want to separate this. You can apply multiple security groups, so you can create a new one that has this particular rule and they can be applied cumulatively. Your choice. So I separated this out. I get back to this security group in 1 second, but I'm just clicking this button so I can get out of here and go back to this. So we assign this firewall setup, getting back to that in a second. The next thing, that was the key pair I mentioned just before. You need to select the key pair that you want to allocate with this new instance so you can actually connect to it. Right? There's a lot of things, a lot of bells and whistles you need to bear in mind. You need to get the security up, but at the same time you need to ensure you can access your own virtual machine. If you don't do that, kind of tedious. The rest is mostly advanced configuration features. We don't use those. You can run scripts upon instantiation. You don't need to do any of that. So you can just say launch instance after that. So while we're launching the instance, which literally takes a bit of time, let's go back to the security groups. You'll find everything like that in the area network again. So security groups were here. So you will have the default security group. You can just have a look. There's basically a set of rules. And some of you may be acquainted with some of the terms you see there, directions, Ethernet type, IP protocol, port ranges, and all that kind of jazz. And this is really networking in a sense that it specifies which ports and protocols your virtual machine can use to communicate with the world. Egress means outward facing, ingress means inward facing, so we differentiate the rules based on this direction. We have different internet protocols. You may be, who has heard about IPv6? Cool. And the security people? Yeah, good. So, we probably need to lose a few words on this one as well, essentially. The idea is there that the old internet protocol, well, the contemporary internet protocol, IPv4, is running out of IP addresses. So in the long term, we won't have the opportunity to add new machines to the internet. So therefore, there was a need to have a revised version, which is called IPv6. In any case, we don't care for this instance. We don't care too much about it. It just says this machine can both communicate using IPv4, using the IP addresses right? The conventional 32-bit ones you usually use, and the IPv6 one, which we don't really use. And it basically says, well, allow any traffic that's outgoing, and allow, in principle, then any response traffic that's incoming. What it doesn't allow you, though, is, if you go back here, it doesn't allow for certain advanced, specific applications to be accessed immediately. And for this purpose, you will need to create a new security group, or in worst case, modify the existing default one. Again, not recommended. By adding an entry like this, it basically says incoming connection over IPv4 via TCP on port 22 is allowed from anywhere. What does that mean in English or in any language really, in any human comprehensible language, please? You can SSH into it. Basically, you can do this weird remote connection into it. That's the main point that I'm going to make. What other rules would we need to create for our assignment? Please. Yeah, that was very fast, but everything like that, yes. So how do we do it in principle? Well, you can create, that's the thing, yet another security group, right? So where you separate your your default security group from the access via SSH from the web rules as well. So what was just mentioned here is basically, well, let's modify the existing rules, or rather add a new rule, and you see something like this. It's a generally the default rules are actually quite useful, but we don't. There you go. Why am I so blind? Okay, cool. So you have various rules there. On the top it says custom. That means you can specify your own route, your own ports. We briefly talked about ports, right? Port 80, port 443, port 8080 for different purposes. But of course, OpenStack knows about some of those standard privileged ports, such as HTTP, port 80. And you can just tick this, and it will just set it up. So basically, well, if you want to communicate via HTTP with this server that sits behind this particular security group, now you can do so, right? You just basically say add, and it will add this simple group, this rule, and actually decomposes this. Now you can see that it says port 80 for incoming from any host. This one means who can connect, and you just say 0000. It basically means anyone can connect. We don't care, because you could constrain in principle to suggest that only particular hosts, like for example your host, can connect, but no one else's, right? So, but no point here in this particular context. The second rule you want to create is a now custom TCP or rule. So following the same pattern, we don't have a sample for this one, but we want to open up port 8080 because you kind of popularly use this for the web service, right? In this case, you literally need to type in, well, it's a TCP connection, so a persistent, HTTP runs over TCP. We have an incoming direction, so we want to have an incoming connection that is allowed. And we want to open the port 8080, and this whole remote thing, just leave it untouched, so everyone can connect via port 80. That's the whole idea here. So we have yet another security rule. That's how complex or simple you want it to be, but fundamentally that's the key idea, that you need to have two security groups. One is for SSH, allowing incoming traffic via SSH. Again, there's a default variant for this one as well. So you simply go down here, click SSH, and we'll pre-populate everything for you. And the other one is HTTP, and the third one is port 8080. Okay, those are all the security groups now. So that's basically your firewall setup. The last thing I had to will have to talk about is the idea of floating IPs. So as I mentioned just before, we have this problem that, okay, we in principle have the idea of connectivity to our virtual machine. We have the firewalling set up, so you can prevent access by unwanted third parties, or only on the ports we want. But the other thing is actually, before actually making use of this, we still need to poke through our own router and the created network to get into our virtual machine. So if you recall the figure from before, there wasn't any sort of virtual machine. You now see the connectivity. By the way, this network topology is really good for debugging to see whether you actually connected the right stuff. You have the internet-facing perspective, you have this router, your own network, and then in there your individual machine. So in order to have a direct access from this internal network to your internal machine, and ignoring this internal private network aspects to it, we have a concept of floating IPs. You probably get around 50 or so. You don't need that many anyway. But you get a few floating IPs that you need to assign, or one of them that you need to assign to your virtual machine. And this one will be the IP address under which your host should respond when you try to access it via the IntentU network. So coming back to the instances, so you can simply create floating IP addresses relatively straightforward. But I'll show it from the instance perspective. Recall, this is the instance I just created. It runs Ubuntu 18.04, flavor M1 Tiny. It currently has an IP address which is an internal one. You can't access one. It's a private IP address. I used 192.168 as kind of a default framework. You may know that from your home routers. They usually use similar IP addresses if you have ever looked at it. You see which key pair associated with this, so you need to have that pre-prepared. And down here you can do a lot of stuff. One of them is, the first one generally, is saying associate floating IP. And that's what you want to do. And what the idea is, which external IP, meaning the one that's visible on the NTNU network, can be associated with your virtual machine. Right now it's one virtual machine, and it has this particular port, right? There's only one port. Had you 5 of those, then you have 5 ports. So you need to be clear which IP address you want to access. You will not have that problem here. And then you need to pick or associate another external IP address, which you just need to take what you get, basically. OpenStack will give you an IP address, and that's the IP address you're going to use. And you simply say associate, and it takes a bit, but then you'll see that it lists both IP addresses down here, and the floating IP is the one by which you can access the system afterwards. The one thing that I haven't done, so there's also the idea of, again, here in this menu, you find security groups. That was basically the firewall settings. So on the right side, if you click on this, you'll see the security groups that are associated with your instances. You can keep the firewalls completely separate from your instances, right? You could have one instance that is only web server, so it has rules associated to web access. Some of them may be for databases only. They may have rules associated for databases, so you can really have a fine-grained association there. But fundamentally here, on the right side, you see the security groups that are associated with the particular instances. This instance, which is the default security group, so the machine can do its stuff on its own at least, and the SSH access, but I also want to now add the web access. So you can just dynamically add this. And now the machine should be somewhat ready for access from the outside world. Okay. Bit of a pain. Most of it's done once. The key pair is created once, security groups are created once, and the network is created once. Once you did this, those 3 infrastructural elements, the creating the instance is relatively straightforward. You pick the image you want, and the flavor of machine you want. Again, it's the important choices. So apart from looking at the tutorial, which shouldn't take you too long to get through, the important choices are highlighted on the slide set that I haven't linked yet, but I will link in the wiki. It basically says the important points. So again here, creating a key pair. When you create one, you download a PEM file. Don't lose it. We come back to that. Then you create the security groups, reusable. You do it once. And then you configure the instance. That's something you need to redo every time you create a new instance. Surprise, surprise. But it's mostly an association of the stuff you've previously configured with this instance. So spinning up yet another instance is relatively straightforward. Or do you guys disagree? The ones that have experience? No problem, right? Okay. All right. Okay. Right. So then you have that instance once you're done. If you want to play safe, you can also reboot it. So I shouldn't waste much time on SSH, but one of the key things is SSH allows you encrypted access to the to your virtual machine via terminal, right? What you do right now when you run your virtual machine, you kind of in your local host, you kind of have immediate access to the command line and can do stuff. You of course need to use your login and so on. But the idea was that usable or human passwords are generally not safe enough for permanent exposure on public networks, such as the internet. So it becomes very impractical to deal with usernames and passwords because eventually those will be, most often brute forced and so on. Heck, you guys, the security people, did you ever do the exercise of just exposing a host with a user login on the internet? Should try it and give it a go and see how quick it actually is taking over. So it's actually quite nice because if you have random brute force attack, you probably have a day or something. Then by dictionary attacks, they'll get quite far. So hence the need for stronger encryption. Again, because we're kind of operating on the open heart at any time, it feels like, meaning we are exposed to the internet. And that's where SSH comes in, which basically offers works based on the private key or asymmetric encryption principles. That is, in order to have a shared secret, that password that you want to think about when you communicate in a wide sense, the idea is that you have a public-private key encryption. And the idea is that only by combining a public key and this private key can you then generate this shared secret in order to communicate with the server side. So if you, for example, have your host, which hosts this public key, no one can access it unless they also have the private key when they connect to it and use it for doing the authentication phase or the connection phase with SSH. only then they can connect. So it's no longer enough just to have a password, but a rather complex key, which is generally held in a file-based representation, a so-called key file. I'm not going too deep on this one, but the key point here is passwords are convenient, and you can easily share them with people. Problem is they're very weak because we are limited. Our cognitive load is relatively constrained. If we have 32 letter long passwords, then we need to use other helpers such as memorize sentences, which is also not clever nowadays anymore. So key files is the only way that we can ensure that passwords, if you want to use that term again, have a standardized length. So how do you access this exercise? You download this PEM file, which you get on the first time. You only get it once. If you don't download it from the OpenStack doing creation, keep track of it, you need to create another one, which is tedious, especially if you have instances running already with your passphrase. But how do you access then your virtual machine? Well, you need to do a few things. One of them is you need to, if you're in Linux, you can use the command depicted above there. You basically say SSH, that's the command that you use to connect. -I means you specify the key file of choice. Then you need to provide the path to the key file. In this case, I've just set home directory, your keyfile.pem. You can name it anything you want, but that's fundamentally the name of the file. Important aspect, the file needs to have a certain permission set. It must be in a way that only you can read it and modify it, potentially no one else. Else SSH will stop or will not use it. It will just say the file is too permissible, I will not use it to connect. This thing is not trustworthy. So you need to have a chmod 700 running on this, ideally. 600 to avoid execution, that's right. But only you can actually read and write from it, not execute it, of course, and no one else can do anything to it. So that's the key idea. So if you see that permission issue, that's most likely the problem. So chmod 600, thank you. So on Windows, the world is different. And you see that, right? There's a lot more points there. On Windows, the world is slightly different. The only tool, to my knowledge, if you know a better one, let me know, that you can use to conveniently connect to this virtual machine is called PuTTY. I think that's the, I don't know how the author wants it to be pronounced. But that's the tool. So it's open source, it's freely available, and it's kind of the tool on Windows to connect to OpenStack instances. Problem is, this thing has an own key format, so it wants you to change or to convert the .pem file you get, which natively runs under Linux, into a ppk file, which is own file format. It's not deadly; it's just slightly tedious to convert this. There's a tutorial linked in the GitLab wiki that explains to you with screenshots, please, how to do it. Yeah.
PowerShell has support for SSH.
Ah, yeah. Okay. Is anyone using PowerShell? No, yeah, you did operating systems already, right?
Yeah.
Yeah, exactly. So they only learn in operating systems.
Yeah, but you can open it and.
Oh, yeah. Okay. You could also.
You don't have to download PowerShell.
That's right. That's right. So if you are on Windows 10, yes, you could. Right. So yeah, PowerShell is an alternative pathway. Sure. Do you want to post a link to it on the wiki?
It's the same. You can just use Linux.
Okay. So in this case, you just bring up PowerShell, it's relatively straightforward, and try use the Linux command. Everyone should have PowerShell on your machines. So basically, you just run PowerShell from the command line, and you should see something like this. And you can just run SSH. I need, sorry?
You have to old PowerShell. 2016.
Ah, there you go. That's the thing. So you need to upgrade PowerShell in some cases. Even so, there you go. Classical PowerShell exercises. Okay, so use PuTTY because that works. And in fact, it's actually pretty much for that purpose only. So PuTTY, how does it look like? Well, it's a small and tiny tool, something like this. And the only thing it asks you to do is write a host name and a port and to connect to, of course. In addition to that one, you will need to provide the, there's two ways of doing this. You can either provide a, the key file that you want to use for authentication here, and then, so basically to a local directory, and then put the host address here. The host address will be something, no, will be the floating IP. But you will need to have a prefix as well, because as part of the IP address, you also need to authenticate with a default user account. And for all Ubuntu instances, as they are run on OpenStack, the prefix is, by convention, Ubuntu. So basically, you don't have a user anymore, because now you have this SSH key. Basically, it does everything for you, and you don't need to worry about any more user password combinations. But in this slide, you just have a default user you connect with, which is called Ubuntu. So when you enter this exactly in this notation, Ubuntu @ and then IP address of choice. And then you connect. Well, now, So it's when you connect for the first time, it will tell something like this: oops, potential security breach. There's a new fingerprint I have never dealt with, meaning it identifies the server that uses a known, has a known public key, but it runs on a different server. So the system or party is alerted that somebody may have hijacked your public key that you have put there. So, and the idea is there: do you want to make this machine, eligible for access? And you just need to click yes the first time. And once you do that, you get here. So I'm not sure if it's legible, but essentially you're just on the command line. That's basically all you see, and you can do everything you want. You suddenly have your full virtual machine at your avail. If you want to quit of this thing, you can do it in the conventional Linux fashion on getting out of it. So that's the key idea of OpenStack on how to get an entire system running. Okay, is that enough to run everything on the assignment on OpenStack?
Copying files.
Oh, we did this.
We're copying them into Docker containers.
No Docker. Forget Docker. So you just need to install Git, clone, and run your stuff. Is there anything else we need to consider? Will our services run like this? Can we just run them? Yeah, please.
Well, I don't know if you already mentioned that you need to open port 8080 on your security groups.
That's a good point. Yeah, that I'm not sure. I think I did this just now, but yeah, that's another good point. Let's go back and just sanity check. So you can always go back and check the rules. You know, you have those 3 rules. Yeah, I think we have this. So what else do we need? Is there anything else?
443.
Sorry? 443. Yeah, if we're on HTTPS, yes, of course. Okay, what else? What is another problem or concern? What's the problem with those SSH connections possibly? Can you just run use? Yeah.
Well, your SSH connection might break, so you could use
Tmax, yep, cool, yep. That's we probably need to use something like that. So the choice of tool we introduced here is Screen. You guys know that thing? Doesn't matter, right? So okay, what's the thing about Screen? Because that may confuse people a bit. Just to get a bit of conception. So everything up to now is enough to connect to your virtual machine and also potentially run your assignment as long as you're connected. Problem is, you want to be disconnected at time, right? So you want to disconnect and leave it running, and hopefully the server will do its job. That's do. Okay. So for unsupervised programs, we have a bit of a problem there. That's the conventional approach. That's the server on OpenStack. That's you having your SSH session. And you can, of course, you could say, well, I create 2, right? One is for the program, one is for myself. I can still do stuff on the server. Still a problem. If that second session breaks, your program is gone as well, because the session will be closed. So there's a concept of terminal multiplexers, and those guys just mentioned Tmax, which is one example of those. What they do is basically you can use your SSH session to create a separate session for for anything really, for running programs independently. So the idea is that this session, the screen session shown on top left here, is independent of the connection that you have developed or created to the server. That's the key idea. And even if you disconnect afterwards, the session will still persist. It will continue to run. And you can ideally reconnect to it and modify it. You can also run multiple sessions that are all independently running from to the server. So that's the idea. And tools that allow you to do this are manifold. There's an arbitrary list of 3 that pop up quite frequently if you look for terminal multiplexers. Screen, Tmax a bit more nice, I guess. And BYOBU, I don't know if anyone has played with this. Looks quite interesting though. So this is a visualization here of Tmax in particular. It shows you the example that you, for example, not only can connect to a particular instance or session on the server, but that you can also do it with multiple sessions at the same time. We're not doing this, that's all a bit going too far. But for our purpose, we simply want to be able to use Screen on the server. So in order to do this, again, if I'm of course going over this a bit too fast to be sane, there is a mini tutorial which is link to today's lecture, but also here it basically runs you through the ideas how to actually create a separate session in using those tools. So if you just run screen, you may need to install it. That asks you for, has some, if you run it for first, well, if you run screen blankly, it just gives you some disclaimers. You can just space your way through, and you end up in a different console. It's kind of slightly confusing. And then you can do stuff in there, right? It looks like a normal console instance that you actually have. Problem is, since all the special keys, such as Control, Control X, Control C, and so on, are pre-populated, it's a bit of a challenge to run those in those sessions. So the combinations of actually getting out of such a session, so to detach, as it's called, from the session, is to run key commands such as Control A D. So Control A and then D, and suddenly you read, oh, I'm disconnected from 1490 blah 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 PS test. What does that basically mean? Well, I run screen.ls now, and you'll see. Hang on, if you do ls means list all sessions. And it shows you all the existing sessions. They continue to run. It's just that you are not connected to them. And one of them is called 1439 PTS0 test. And this is basically the process ID on the operating system it runs with. So it's independent of your operation. You just can poke or connect to it. You can also create named sessions. You do that with screen.s name. And it's slightly more descriptive. So it's yet another session where you can do something else, I don't know, an update because it's fun, or I shouldn't have done this, but just for the visualization. And again, you can switch out of it by using Control A D for detach. Screen.-ls, hang on. And you now see, okay, we have two sessions. One is called like 1456, process ID .name, that's the name I just gave. So it always has this prefix of the process ID, over the other one. So both of them are still existing and detach. If you want to then, of course, the obvious challenge is to reconnect. So if you want to later, when you log in again, reconnect, you simply can try screen-R, and then you type the process ID and use tab completion. It makes your life reasonably easy, and you're back in that session where you were. So if I'm detaching again, and I'm actually exiting the session entirely, so now I'm no longer connected to that server. You should be, oh no, you can easily reconnect. Just showing you an example again. Ubuntu add. So, don't forget the add. Reconnect to your server, and if you run screen.-ls again, you should see the sessions are still existing, right? So you can, using screen-R reconnect, you can connect to any of the sessions of your choice. You just need to get the name right. So that's really still running top in the background. So that's the idea. You get into screen, get a new session, you go there, and then run Control here, Control AD to disconnect, and that's all you need to do. So think about those sessions as a kind of a session running inside a session. It's not quite; they're actually independent of each other. But if you want to exit, if you want to destroy one of those sessions, of course, you can simply exit out of them. In this case, it will just say screen is terminating, and you should no longer be seeing that particular session in the list. You only have one existing remaining session. So it takes a moment to get acquainted with this, because the commands are tightly a bit cryptic, but I think this cheat sheet and the description basically says exactly what I just did. So you can just briefly run through it and get the feel. So task for you: run OpenStack, create security groups, get your key password, this network setup by following the tutorial. I'll show you the tutorial. It's in here. So that's provided by Eek down there. You literally, it runs you through the IDE as well. So it basically tells you a lot of the stuff I just told you, and you literally follow it, and then you should be left with a running virtual machine. The only thing is here again, the security groups. They modify security groups here. You can add new ones, and they don't accommodate the port 80 and port 8080 for your access. I make a comment on this in the issue, but those are two ports you need to add and open as well. Otherwise, you will not have access. I will make an issue to remind you of this. The rest should be the same. So we need to create key pair, security group, network. That's done once. then create this instance, and then in the instance get a feel of how screen works. Screen also works, of course, in your local virtual machine. So for the sake of testing and trying it, it's all the same. Right. Any immediate questions? I know it's a lot, but first of all, I provide you a slide set, and again, there's I think everything is somewhat tutorialized, either in this thing here, the issue, but also using the short intro on screen. So it's like really a one-pager on how to get comfortable with screen. Anything else? Okay. Well, okay. In all our cases, well, you can take respective breaks, or of course we're here for your assistance right now in terms of your assignment and the like. But try to get connected to OpenStack once you can. Run through a tutorial. It shouldn't really take you too long to get comfortable with this, and it's rather step-by-step following as opposed to requiring any particular creativity.